Okay, so in the previous video, like we already discussed, right, how to run a test for population proportion, and then for all the example in the previous video, we are talking about the small sample size. All right, so when you want to test the population proportion, p equals to something or p greater not equals or whatever to something. All right, then generally when the sample size is small, you are using binomial distribution to run the test, right? Okay, so for today, we are going to focus on if you are having a large sample size, then how are you going to run the test for the population proportion? Okay, so here they already mentioned when the sample size is large, you can calculate the probability by using the fact that binomial distribution, right, can approximated by normal distribution. So the concept is more or less the same like what we learned before, like in AS level. Okay, so in AS level, under some a certain condition, you have to change the binomial become normal, right? So since binomial is a discrete random variable, and also the normal is continuous random variable, so when you want to do the approximation, right, you need to do the continuity correction. So the concept and everything is exactly the same like what you learned before from binomial to a normal. All right, so how or when are you going to change binomial become normal? So you need to make sure that your MP is greater than 5, NQ is greater than 5, and also N is large. So there are three um, conditions that must fulfill when you want to change binomial become normal. All right, and when you change binomial become normal, then the normal mean is NP, the variance will be NPQ. So this part is exactly the same like the AS syllabus that we learned before. All right, then here, when we want to run the test, right, originally when we are having binomial distribution, when you want to run the test, you have to use p-value approach. Then again, when you want to change binomial become normal distribution in a large sample size, then in this case, you can use either critical value or p-value. So you can see that when you are having the normal distribution, right, in your hypothesis test, then generally you can apply both method, either one. But if let's say you're having only the binomial distribution, okay, with the small sample one, then you have to use p-value. All right, so only normal distribution, you can consider both method are critical value or p-value. All right, okay. So in marking scheme, for this kind of question, binomial change to normal hypothesis test, usually they are using the critical value. But for me, I will still prefer p-value. Later, I will tell you why. To me, I think p-value is easier, okay, to run. When I want to run the test, it's slightly easier compared with the critical value. But for marking scheme, they are using critical value. All right, so I think they will still accept both methods, so no worry about it. All right. Okay, so let us continue. When you want to use normal distribution to run the test, right, for binomial distribution, then what is the test statistic? So this is the formula for test statistics. So it is Zx minus MP. MP is the mean divided by square root MPQ. So MPQ is the variance. So square root MPQ means the standard deviation. So this is the formula for the test statistics when you are changing binomial become normal. All right, so there's one important part that I want you to take note. It is not the same as the test statistic for normal distribution. Because some students, they might actually get confused to this. All right, last time when you are having originally normal, right, you should ever use the normal distribution one, you are using sample mean as the test statistics. So it is actually, sorry, you are using sample mean as a test statistic. So actually how to get the Z is sample mean minus the mu divided by standard deviation over square root n. So please compare these two and don't get confused. All right, so for this test statistic, it is purely only for those questions that is originally normal distributed. And then we are testing about the population mean. So we are using this. Okay, But if let's say you are having binomial distribution and you are running the test for the population proportion, when you change it become normal distribution, then this is the test statistics. So please don't confuse about these two. All right, I think it is quite common that some students might confuse between these two. Okay, all right, so here one more extra point: when alpha is not provided, then 5% will be the standard alpha. So alpha means the significance level. Okay, so all these are some small details, and then the steps of carrying out the test, right, generally are still the same like what we learned before. Okay, so I will discuss a few example with you here, then you can try out the other one, okay, in the notes. So for me as an example, I will discuss example 18, then you try example 19 on your own. All right, okay, so let us start. So Caroline is asked to test whether a coin is biased in favor of heads. So if let's say they are talking about in favor of heads, that means the probability to get the head is higher, right? So it will be more than 0.5. Okay, then using a 5% level of significance. Okay, she tossed the coin 100 times, this is the n, and obtained 57 hits. So you are testing the population proportion. So you should know that this is your observed value given by the question. This is the observed value. Okay, so they want you to carry out the hypothesis test, stating your null and alternative hypothesis clearly. All right, so from here, I know that I want to test for population proportion. Okay, that in favor of heads, this in favor word tells me that the probability should be greater than 0.5. That means has a higher chance to get a head. Okay, so I will start writing out my null and alternative hypothesis, which is the first step. Okay, so my null hypothesis will be p equals to 0.5. And then my alternative hypothesis will be p greater than 0.5. Okay, then again, I will write out a sentence about the alternative hypothesis. So a coin is biased, okay, in favor of heads. This is the meaning for alternative hypothesis. Okay, so this I completed my first steps. All right, then now I want to go for the second steps. So for the second steps now in our previous video, right, it should be something that you need to calculate the p-value. Right, okay, so how to calculate the p-value? So you write out x is binomial distributed, then your n is 100, probability is 0.5. And then if you look at this one, you will realize that, oh, the n is large. This is n, right? So n is more than 30. And then you check NP. When you take 100 multiplied with 0.5, it is more than 5. When you check for NQ, 100 multiplied with 0.5, you also get more than 5. So under this condition, right, you can actually change, or you have to change binomial become normal distribution. So I change it become normal distribution. How to get the normal distribution mean? You take 100 multiplied with 0.5, NP. NP is 50. So you take variance NPQ, you'll get 25. Okay, so just a small reminder for you lah. So this is NP, then this is NPQ. Okay, and then according to the binomial test that we carried out before, right? So you want to calculate the p-value. So how to calculate the p-value? We are using observed value. So x 57. Okay, so this is 57. All right, so you have to ask yourself, what is the sign you have to put? Either is greater equal or smaller equal. So which one? All right, so I think you should remember this already. So to decide the sign, there are two ways for you to decide it. The first one is look at alternative hypothesis, greater. So this one will be greater equal. Or you can check on the mean. So this is the mean, right? Okay, so you can imagine on the number line, mean is 50. Okay, and then you're having 57. And when we calculate the probability, we want to calculate the probability for or the area for the sides one. Okay, either left hand side or right hand side. So you can see that you want to get this area which is greater equals to 57. So this is another way for us to decide. Alright, so I'm following exactly what we learned before in the binomial distribution test. Right. So you want to get x greater equals to 57 now. And of course, because x now you already change it become normal distribution, right? So you have to standardize it become Z. Okay, so to change it become Z, you need to do continuity correction. So greater equals 57 means include the 57. Continuity correction should be negative 0.5. Then minus the mean. So minus the mean is 50 divided by standard deviation. So standard deviation is square root 25. Okay, so I will highlight this continuity correction because a lot of students will always forget about it when they want to do this calculation for p-value. All right, so you have to minus or you have to do continuity correction according to the sign that we have. All right, so I will highlight this side as a reminder. So what do I have here is Z greater equals to or greater to 1.3. All right, then after that I will get the probability lah. So 1 minus 0.9032, I will get the p-value which is 0.0968. So this is my p-value. Okay, all right, so after I get my p-value, then I want to compare it and compare it with the diagram, right? In the diagram to see whether is it in the rejection region or acceptance region. Okay, so previously in binomial distribution, you just draw a bar chart like that, right? But because now you already change it become normal distribution, therefore you are allowed to use back the normal graph. Okay, the bell-shaped curve. All right, so this is a one-tailed test on the right. Therefore, you should know that this is your rejection region. And then for this rejection region, the whole area here is 0.05, which is the 5%. Okay, then now if you look at your p-value, your p-value is 0.0968, which is larger than the area 0.05. So you can imagine that this is the area that you get, the blue color part. Okay, so this is the area that you get, and the blue color part. So the blue color part is 0.0968. Should be greater than 0.05, right? Because 0.05 is a smaller area. So 0.0968 is a larger area. So you look at the area. So after you sketch the area already, so you look at this value itself. So this line, the borderline here, the value here, falls under the acceptance region. Therefore, from here, you can make a decision. Okay, so is fall under the acceptance region. Therefore, we do not reject the null hypothesis. Okay, and after that, what is the conclusion here? Since you didn't reject the null hypothesis, so this coin is not biased. All right, in favor of heads. Okay, so this is the complete steps. So you will see that if I change binomial become normal, right? According to my steps, I'm still following exactly the same steps as what I have in the previous video. That means I'm using the binomial method, the p-value method to calculate and carry out the test. Okay, just that the graph here, instead of drawing a long bar, I change it become the normal curve, the bell-shaped curve, because I already changed my distribution become normal. All right, so that's the proper way. Okay, so this is a complete test for binomial change to normal distribution test. But you can still see that we are still testing about the population proportion here. Okay, all right, so this is the p-value method. How about if let's say you want to use critical value method? All right, so if you want to use the critical value method, okay, I will put it in another color. First step is still the same like what we have here. So this is still the first step. Okay, so this is still the first step if you want to use the critical value. All right, then the second step is usually I will want to draw a graph first. Okay, so usually for second step, I want to draw a graph first, or maybe you can put it in the third steps. All right, up to you. Second or third, you can change it, is okay. All right, so for the second step, I will draw a graph and then I will try to shade the rejection region. So this is a one-tailed test on the right. Therefore, my graph will look something like this. So again, why I make it become normal distribution? Because I know that later I will change it become normal. So I'll draw a normal graph first. Okay, then after that I want to get the critical value. So what's the critical value here? Okay, so again, critical value, if you find out from the table, you will get 1.645. So this is the second step. So the third step, I want to calculate my critical value. Oh, sorry, I want to calculate my test statistics. So for test statistic, okay, so maybe before I calculate the test statistics, I should actually state out that I actually change the binomial become normal. So 100 and 0.5, I will change it become normal distribution, which is 50 and also 25 here. All right, so I want to calculate the test statistics. Okay, so test statistic. So the test statistic will be Z. All right, so Z X. What is the value of X? 57. Okay, then you have to do continuity correction, which is minus 0.5 and then minus 50 divided by square root 25. Okay, so again, this is the part that usually students will do it wrongly, the continuity correction. In my opinion, right, if you want to use the critical value method to solve the test, to run the test, this is the part that is quite troublesome for me because without the sign, because here I always write equal. Like when you want to calculate the p-value, right, you write out the sign greater equal. So the greater equal tells you easily what kind of continuity correction you want to make, either plus 0.5 or minus 0.5. But if you want to use the critical value to run the test, this is the problem because I don't have any sign here. I have equal sign, but equal sign doesn't help you to decide what is your continuity correction. Is it greater or smaller, or is it minus or plus? All right, so this is a problem that we have. So if you want to know whether is it minus 0.5 plus 0.5, you still need to refer back to this one. So that's the reason why I still prefer p-value approach. When you change binomial become normal distribution, to me it's smooth. Everything is very smooth. All right, but for this one, you might need to think further or maybe think more to get the correct continuity correction. Okay, so I highlight it here also to make you take note about it. Right, so if you calculate it, you will get 1.3. All right, okay, so the 1.3 here will be your test statistics. So what happened to the test statistic? You need to put your test statistic into the graph to decide. Okay, so now 1.3, because you know that this critical value is 1.645, so the 1.3 is before 1.645. Correct or not? So the test statistics falls under the acceptance region. Therefore, you do not reject the null hypothesis. So after you decide, you copy back the decision and also the conclusion. So this is step number 4 or 5. 4 and 5. Alright, so I hope that you can see the difference by using the critical value and also the p-value. Only normal distribution allow you to use either one of the method. Okay, so for this binomial changing to normal one, I still prefer using the p-value. Okay, so as what I mentioned, the biggest reason is because of the continuity correction. If I use the critical value, the sign here, the equal sign here will not tell me should I minus 0.5 or plus 0.5. But if I use the p-value approach, this sign itself will tell me very clearly what kind of continuity correction should I make. Is it plus or minus? All right, so that's the biggest reason that I prefer p-value. So in marking scheme, generally the main steps they provide is still the critical value, but actually they will attach also the p-value, okay, in the marking scheme. All right, just in case you are using p-value to calculate it, they will still accept it. All right, so this is what we have for example 18. Okay, so for example 19, I will want you to try out on your own. Okay, then I will provide you the answer later in the PDF file. So for your information, right, the answer that I provide you here will be all based on p-value approach because I'm using p-value approach all the while. All right, so for critical value, I will only show you for this example, okay, to let you know actually how are we going to carry it out in critical value method. All right, okay, so I'll stop here for this video. Then next video, we discuss another two examples.